Hi guys, Buildzoid here, and this is a follow-up to the previous 30-minute OC challenge video, because past Buildzoid, well, he really sucked at Maxwell GPU overclocking, and also, yeah, I'm, like, when did this video upload? I think, like, when did it upload? Why doesn't it tell me when it uploaded? Whatever. Um, like, a couple minutes ago, so the video's not very old. So basically, I just spent maybe like an hour. Yeah, maybe an hour. I don't know. My sense of time is terrible, so I actually have no idea how long I've been at this. But yeah, so in the OC challenge, the goal was to get 21,000 points in Firestrike. Now, the reason why I set the target as 21,000 points is because if we look at the 980 Ti 3D Mark 3D Mark Firestrike rankings on Hardware Bot, there's a lot of scores up here, like a lot of sort of ambient scores approaching 21K, right? So if I go like air cooling, and then we go top one. So the best air cooled score is 2050. Best stock score is just under 21K. The best water cooled scores are kind of ridiculous because that guy's running 1700 megahertz, so he's on a water chiller. But you know, if we ignore the people who are running absolutely insane GPU clocks, no, there's a few scores that are at 21K. Actually, I wonder how he's, huh? Oh man, that's CPU. Yeah, that CPU carries hard. That CPU score carries really, really hard. Um, But, you know, so 21K seemed like a realistic goal for a Z490, like a 10700K plus a 980 Ti, and it shouldn't have really been that difficult. But it was. It was very difficult. After 30 minutes, I was nowhere near 21K. But, of course, I wouldn't be making this video if I hadn't broken 21K. Now, there is sort of a lot that I've done to get here, so the CPU is at 5.3 gigahertz now instead of 5.2. The memory is still at just 4000 CL16 because like the memory doesn't matter that much. Like it does help, but it's not, you know, it's not critical. Like if I completely, like if I was going for multiple hours, then yeah, I would dial in. Like the thing is just like for me, it's like, you know, if I want to put even more effort into this score, I could probably just go and grab the 7940X and just destroy this score. And even the 3950X would actually probably should do a decent job. It's only really like the Threadripper CPUs that are absolutely atrocious at 3D Mark, which, yeah, it's kind of fun. But anyway, so CPU got a slight bump in clock speed, which is why it's now getting 29K physics instead of 28.5K physics. I also discovered that the voltage control in Afterburner, the like extended MSI voltage control is actually like it makes the GPU really, really unstable. Like I have no idea why, but if I start using this slider up here, yeah, that's bad. Don't, that slider is very, very bad. However, I did end up bumping up the memory voltage because yeah, the memory does actually scale with memory voltage. So I was wrong about that in the 30-minute challenge, but that's the thing is like with 30 minutes there's not enough time to just methodically go through all the things to test, and so I really thought like, you know, using the static voltage would work better, and then of course we had the memory stability issues from the fact that I was running an unstable DDR, like memory overclock on the CPU side of things, and so everything was awful. Like it's entirely my fault. Everything was awful. Um, yeah, so that static voltage control in Afterburner is really bad. Like, it is terrible for stability. And it makes me wonder if maybe I shouldn't, like, just... Because the thing is, it is a Lightning, and it should technically have, like, software voltage support, but I'm starting to think it would be better if I modded the voltage control circuit for the IR3595 in a... Because here's the thing. So, these... and yeah, this video is turning into way more than it was supposed to, but anyway, I'm actually gonna pull up some documentation. So let's grab that. Okay, so here is our documentation. So this, if I'm not mistaken, is the voltage controller used on the 980 Ti Lightning. It's an IR3595, 8-phase digital controller, blah, 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 blah. The important thing is PWM vid. PWM vid is very important because it's NVIDIA's, it's like a special NVIDIA standard of voltage control where they feed a PWM signal from the GPU core to the voltage controller, and the voltage controller then turns that into an analog voltage level, and that is then used to set the output voltage of the VRM. So the cool thing about this is that if I actually pull up some more documentation, just gonna go there. That's not the correct documentation. Idiot. There we go. This documentation. There we go. Much better. So, NCP 18 pages. Okay, so basically we have this lovely circuit. I'm not used to using Google Chrome, but yeah, so we have this lovely circuit right here. So VREF is a reference voltage level of 2 volts. Vid buff, this is the output of the PWM vid. And then we have ref in, and this, whatever voltage is applied to ref in is the output voltage from the VRM. And this is the PWM vid sort of like implementation circuit. Basically, every voltage controller that has PWM vid support should have this circuit right here. Like, not 100% on that because unfortunately International Rectifier doesn't give us full documentation, like doesn't give, this is a data short, so this really isn't like a, this isn't really documentation. This is just like marketing speed. Like this is voltage controller marketing right here, because they don't give you any implementation details. But anyway, so this circuit should be present on the 980 Ti Lightning. And what's cool about this circuit is you can basically use it, like you can do offset voltages on this by just fiddling with the resistance between VREF and ref in, because that'll just offset the voltage. So, and I want to mess with that because I think that might be better for overclock, like high volt, like that. I think that might be better for stability than like straight up static voltage. Because if I wanted static voltage, I can just disconnect the vid buff circuit. And that's the other cool thing is I can actually just use a switch to have the voltage control. Like I can switch between fixed voltage and offset voltage mode, which would be really, really cool. So yeah, I can just use a switch to, you know, disconnect and reconnect the vid buff to reconnect and disconnect the vid buff, and then I can have just a potentiometer between VREF and ref in, and bam, we got all of the voltage control you could ever need. And the thing is, and like the reason why I'm thinking of doing this is just like I do want to take the card on Sub-Zero someday, and based on the fact that at ambient it really doesn't like the static voltage mode, I'm wondering like maybe it would be better if I use like offset voltage mode even Sub-Zero. It might not be necessary Sub-Zero. I don't know how the card changes, but you know, I'll always have the option. So yeah, that's what I'm thinking of doing. And that circuit really should be present on the 3595. It's going to be a pain to hunt it down. I guess I could try ask MSI for full documentation for this controller. I could try that. I don't think that they'll actually... Well, we'll see. I might be able to get some full documentation. Unfortunately, if I get full documentation, I can't show you anything in the documentation because it's NDA'd. That's why you can't just search it on Google, which is really annoying. Anyway, so yeah, that's one thing I learned is like static voltage on Maxwell very bad apparently. So don't do that. But the memory does overvolt, so that's not like the memory does scale with overvolt with extra voltage. The memory is not maxed out. Like I haven't pushed the GPU to the point where it stops being able to run the benchmark. I've just pushed it to the point where it spits out over 21K. So there's probably still some headroom left. Now then, in terms of what voltage control I did use, I just have the voltage in, you know, I have the plus 50 millivolts maxed out in precision, which is why I got the idea, oh, maybe, you know, like instead of trying to override the voltage in hardware, I should maybe offset the voltage in hardware. That might be better for stability. Like, I'm not sure, but I can mess with that. Because here, like on ambient, offset seems to be the superior way of doing things for the core voltage. Now, the GPU ultimately tops out in terms of core clock at 15, 16 megahertz, and that is actually maxed out. If I push it any higher, it's going to crash in GT1. max temperature during all this benchmarking was just 48 degrees. Like the heatsink on this thing is an absolute beast. So yeah, that I'm a big fan of that. Did it ever max out the power limit? Oh, I guess it did. Oh, so it looks like it does eventually hit the power limit, so that's fun because it's at 98.8%. So I'm assuming that it probably did end up power throttling. Um, because I think the way GPU Z reports the power limit is it rescales always to 100%. So, not sure. I wonder how much power it pulled in terms of watts though. 280. That's not much. Maybe it wasn't power throttling then. Either way, I'm gonna take care of the power monitoring circuitry. I don't really care. Like, yeah, it's a Lightning, but it's got a chipped corner, so it's no longer like a collector's mint condition Lightning, so I no longer care. And it's just like if I'm gonna be modding the vCore controls, then I'm gonna be hard modding like some power circuitry bypassing is not gonna make much of a difference to me. So the other trick is because you'll notice that yeah my 980 Ti is scoring great, but it's not actually running that higher core clock if you compare it to some of the other scores in the rankings, right? Like if we look at the other air-cooled rankings, like this guy's at 1547. Well, actually, I think that guy's a friend of mine, and actually he's on a 9900K, so it's not like a massively. Oh, his score's actually valid. So yeah, he's not running LOD. So the thing about benching for hardware bot rankings and not like 3D Mark website rankings is hardware bot very explicitly allows basically like a lot of people would consider it cheating. But the reason why this is a thing is because basically back in the day there was no way to prove that somebody was modifying the level of detail. And now 3D Mark will actually detect it, so my score won't get validated on the 3D Mark website. But back in the day, it wouldn't do that. And because HardwareBot values the integrity of their database more so than making life easier for beginners. Yeah, if you're benching 3D Mark Firestrike for hardware bot rankings, you can modify the level of detail. So that's what I've done. That's part of why my score is so high. Or if you're on an AMD GPU, you can disable tessellation. So if you're benching any AMD GPU for hardware bot, always disable your tessellation. Do that. It's a huge performance booster. Um, so yeah. Anyway, for NVIDIA, it's mostly just LOD, and LOD doesn't really have that much, like, it doesn't have as much impact as, like, tessellation disable, but yeah, so I do have LOD set, and the way that works, and man, this video is turning way longer. Like, I thought it would be just a short follow-up, but nah, and this is fine. Like, this is the interesting part of overclocking to me. Well, honestly, I'm not a huge fan of, like, the software tweaking side of things. Like, in my opinion, it would be much better if I never had to see this right here ever again. But I like big scores, and I can't lie. So yeah, there's that. You know, it's just like, oh, this is legal, and it makes my numbers bigger, therefore I will use it. And also, like, this isn't that difficult to do. There's other tweaks, like for example, my SuperPi 32 million is never going to be very good because I'm not going to install Windows XP for it. Just no way. Like, sure, it might be way, way faster than running it on Windows 10, especially when, you know, we're talking about my Windows 10, where it's just like, it's probably seen like 10 different motherboards. It's never been properly set up. And I just keep installing crap on top of it like there's no tomorrow. And at some point, I'm like, why doesn't this OS work anymore? But anyway, so the trick to get LOD working is you get NVIDIA Inspector. And I have some ancient version, and I'm not sure like how it works on newer versions, but I have NV Inspector here, 1.9.66, I think. And so the first thing you have to do is you have to go to this setting right here, which is transparency super sampling, and you have to set it to replay mode all. Any other setting is going to do weird stuff. So AA mode, replay mode all. And then you just have this setting right here for LOD bias, and you can just punch in whatever, like I can just punch in whatever number I want, and it'll convert it into hexadecimal for me. So if I want like 30, I can set 30, apply changes, and it converts it into hex, and yeah, so there. It converts it into hex for me, and and it applies that. So now, and what LOD is basically it's a texture scaling setting. And so basically if you have a really high level of detail set, like if you set the level of detail really high, I think it basically just blurs all the textures to hell. As in, it uses really, really low resolution versions of all the textures. And so the GPU is doing like less texture work, and therefore you get a better score. So yeah, it's basically cheating if you ask me. But it like the thing is there was like on the AMD side we have tessellation disabled, which is in my opinion far worse because it makes much more of an like it has a far bigger effect on the overall score than LOD does. Like this really doesn't do much compared to what tessellation does, especially on some older AMD GPUs. You disable tessellation and the gains are absolutely ridiculous. Um, Anyway, other than that, I have, well, this is set. That is anisotropic sample optimization. I don't know that that does anything. Like, I mess around with the settings in here just because, like, they're available a lot of the time. Anyway, texture filtering, no negative load bias, quality enhancements, high performance. So texture filtering quality is high performance, which you can actually set that through the NVIDIA control panel if you want to. And actually, I set it from the NVIDIA control panel because I can't, like, I don't normally, like, the main reason I use the NV Inspector is just for the LOD. It's not for any of the other stuff. Then we have pre-rendered frame limit, which I think I have it set to, oh, that's just set to 0. Or then I have power management set to high performance, triple buffering is enabled, but that's OpenGL, which is really confusing. If you look into the NVIDIA control panel, like, it just says triple buffering. I don't, or does it specify that it's for OpenGL? So anyway, that shouldn't do anything because it's for OpenGL, damn it. Um, but yeah, and then nothing else is changed anywhere. And well, this is just like that's how that comes down there. So, and what does LOD do to Firestrike? Well, it makes it very, very blurry. That's what it does. So let's run some Firestrike, shall we? The score might go up, actually. Because right now, the GPU score that's there is not the highest GPU score I've seen so far. Like, the highest GPU score I've seen so far is 22,630. And right now it's 2250, like 22,550. Yeah, so this is what LOD does. Um, Now, not all benchmarks are this bad with it. I think I think the Firestrike has some kind of like full screen like texture effect going on, and that gets blurred to hell, and that then blurs the entire rest of Firestrike. Um, so yeah, if you do this in like Vantage, it just looks like everything is made with like single color textures. Um, Depending on how high you set the level of detail. But basically, I can set it so high that you just end up with textures that look like they're just one color. Um, so yeah, so that's how Firestrike looks with this. And here's the actual system. So yeah, there we've got the T4 Team Group T-Force Extreme ARGB 3600 CL14 memory sticks clocked to the 4000 CL16 because I chose the wrong motherboard for running 32 gig. Well, the thing is, I think I was pushing the settings a bit too far. Like, there's a combination of things. I've not messed with 32 gigs of memory on this motherboard very much, so I think it's a mix of, like, I have the settings wrong. It is a daisy chain board, which is making things more difficult than, it could be. But, yeah, like, part of it's also, like, I've not really run this much memory on this board that much. Then we, of course, have the Lightning with the maxed out fan speed, and then just the Arctic. And this is an old Arctic AIO. It's not one of the new ones. This one's still an Asetek pump and everything. So yeah. Anyway, back to Firestrike, and yeah, see, so this is what it looks like in other benchmarks. But Firestrike's first two GT tests have like they just get blurred horribly. But normally LOD just looks like this, where you basically have no textures. Um, or almost have like no textures. And now we're going to go back to blurry. Actually, it might be some kind of post-processing effect that makes like Firestrike's graphics tests get well like this. But either way, yeah. So that's what LOD does, and it basically boosts your performance by, I think, like 1% or something. Like, it's really not that significant considering how much it destroys the image quality. Um, it's like 1 or 3%. So like, it's single digit percentages. And yeah, so it looks horrendous. Um, but it boosts your score. And this is actually the, oh man, what happened to the combined? So unfortunately, combined score just randomly goes up and down. That's just a thing it does. It's super inconsistent. Like Firestrike is not a like, and the thing is, Windows 10 makes that worse. But yeah, that's just a thing. So if I set this back to replay mode off, because I'm actually wondering how many points I'm going to lose at this point. So we're going to rerun that. Sorry for wasting your time. You can leave the video at this point. You can like, you can subscribe, you can share. You can go into the description and like support me through Patreon. There's also the AHOC Teespring store where you can find shirts, stickers, posters, you know, the usual YouTuber merch. Um, yeah, both of those help out immensely with running the channel, so it would be much appreciated if you check them out. And yeah, that's it for the video. Now I'm just gonna watch. Like I'm still gonna show you how much of an effect LOD has, but because I'm actually wondering. Because I basically went from the really crap settings that I had in the 30-minute OC challenge video to, like, I turned on LOD really early. Like, it was one of the first things I did because I was like, oh my god, I can't get this GPU to clock any higher. And so I just threw LOD at it as sort of like, oh, last ditch effort. Or more like I just did all of the driver settings as like last ditch effort to get some more score out of it. And then I realized, wait a minute, the memory scales with voltage, so I actually don't know where this tops out. Speaking of I don't know where it tops out, I still haven't crashed the memory on this. Like at this with the higher voltage settings, I've not crashed the memory yet. So I don't actually know that the memory is maxed out right now. It probably isn't. But don't worry, I'm not going to waste your time with that. I don't think that's really that interesting. I guess I could just run the graphics tests, but... Well, no, I could actually just run the... no, I want to run the whole benchmark. Because the thing is like the overall score is a combination of like your CPU score and your GPU score. So even though LOD probably has a pretty... Like the effect... Like the effect LOD has on the overall score is smaller than it has on the GPU score. Because like this right here is entirely CPU bottlenecked. This scene right here, even though LOD still blurs the textures, that's just because the GPU still has to handle the textures. If it drops below 20K, I'm gonna be annoyed. And there we go. Okay, so yeah, it really doesn't make much of a difference. It's like 500 points, which is like, who cares? So it's nothing like tessellation on AMD, because on like if you take an old enough AMD GPU and you disable the tessellation, it's like it is such a massive effect. Like you can go from, yeah, like an RX 580 with tessellation turned on, I think is like 15K GPU score. And without it, and an RX 580 is like a very late iteration of GCN where AMD, like GCN's evolution was basically more stream processors, more clock speed, and more like more optimizations to get better tessellation performance. So like if you do if you turn off tessellation on something like a 7970, I think it's like plus 20% or something ridiculous like that. Like it's double digit percentages for sure. I don't think it's more than 20 though. But yeah, even on like a 580, you can go from like 15K to 18.5K by disabling tessellation. Whereas here, like you turn LOD on or off, and it changes the score. Like the GPU score has gone down like 700 points. The overall score has changed by 500 points, and of course, combined has gone down a bit as well. Combined went down the least because it's the slowest test, but um, yeah, so there, that is actually it for the video. I already did all the shilling earlier, so thanks for watching, goodbye, and yeah, goodbye. I just need to hit the stop button. I'm so not used to not having to do the whole outro. See ya!